Hi everyone! How can the aging condition of a tank be checked without destroying it? Our topic can be structured in 3 parts. First, an economical point of view. Why is state of health monitoring important from the economic perspective? Second is the scope of a so-called state of health monitoring for Type 4 pressure tank. And the third is the state of the art. There are a lot of different solutions for monitoring carbon fiber reinforced plastics. I'd like to pick out one possible solution for a state of health monitoring system. From a purely economic point of view, there are several factors that constitute a business case for state of health monitoring in development, production, and in the customer. Reduction of the safety factor by monitoring the tank. The burst safety factor of the design can move closer to the limit of the safety factor of the legislator. At the same time, the risk of bursting can be reduced. When the tank is equipped with sensors, more evaluable data can be generated during batch testing. The service life of the tanks, even if they are used a second time, can be extended by state of health measures. The video shows a cyclic pressure test, in which the pressure is built up to 900 bar. We start at 0 bar, go up to 100 bar, back to 0 bar, up to 200 bar, and so on. The risk of rupture due to material defects, misuse by the user, or technical defects of the gas station. This can be minimized with a continuously monitoring. It is amazing how much a tank elastically deforms during cycling. In the case of production liability issues, stored data can secure the customer against third-party claims. In order to define the scope of a state of health monitoring, I have to explain the damage mechanisms of a Type 4 pressure tank. The mechanical defects in the sealing components or plastic liner leads to leaks or a higher hydrogen permeation rate. Defects in the reinforcement can be traced back to 3 effects. First, interfiber breakage is a defect in the matrix. Second, delamination is a defect between different fiber layers. And third, fiber breakage is a defect in the fiber itself. But how to measure the defects? Hydrogen leaks can be monitored by pressure drop over time as a function of temperature. To censor defects in the reinforcement is more difficult. For example, it can be monitored by acoustic emissions or strain. In the graphic, we can see the strain and the force during lifetime of a pressure tank. For lots of cycles, the stress-strain curve shows the same gradient. Because of aging processes after thousands of cycles, defects like interfiber breakage happened. And a result of the defects, the tank becomes softer and the gradient of the stress-strain curve will be flattened. Acoustic sensors can hear the sound of the breakages during lifetime, especially during filling processes. Strain measurement on the tank can detect the lower gradient of the stress-strain curve. Most modern state of health monitoring systems for carbon fiber reinforced plastics are based on acoustic emissions and strain measurement. Combinations with pressure, temperature, and acceleration sensors are also possible. Pressure tanks installed in vehicles make acoustic analysis more difficult due to disturbances such as vibrations, hail, or failing rocks. In the video, we see the application of different sensor types on the tank. Piezo sensors for the detection of acoustic emissions and a carbon fiber strain sensor. With the help of a binary machine learning classifier, a healthy tank can be distinguished from a defected tank. The machine learning classifier can be trained with the tabular data from development tests such as bursting tests or pressure cycling tests. With the help of the shown state of health monitoring systems, it is possible to define the condition of the tank. This happens by the use of limit values, characteristic maps, and the decisions of machine learning algorithms without destroying the tank. If you liked this video, please subscribe to our channel and leave a comment. Also check the link below to get more information.